Hi guys, today we're going to be talking about graphing polynomials. Specifically, we're going to start with talking about graphing cubics, and then we're going to move to a more general graphing of all polynomials. So first, this is standard form for a cubic. We know it's standard form because it's going from highest power to lowest power, and you can see 3, 2, x to the first is just x to the 0th is just 1, so you don't see the x, and that's why it's highest power to lowest power. And I also want to note that this cubic, since it's a cubic, has a degree of 3, and the degree is just determined by the highest power. Our highest power is 3, so it is a degree 3 polynomial. Here I have graphed the parent function of a cubic, f of x equals x cubed. I've used my kind of points around my standard points for graphing a parent function, points that are around the origin that show the general shape of the graph. And it's just -2 cubed is -8, etc. to get these points. And I've plotted them, and this is generally what it looks like. My shape is a little bit off because I'm not very good at graphing these. I always get my curve just slightly off, but if you look up what the curve should look like, it'll look a little bit smoother and a little cleaner. But we are going to talk about the domain range, increasing, decreasing, if it's even, odd, or neither, and it's where it's positive and negative, just to give us a good reminder of these things. So domain is how far to the left, to how far to the right. Because of these arrows, we're going to the left and right forever in both directions. So there's our domain. Our range, same idea. Our lowest point is -infinity. Our highest point is going to be infinity. We are increasing, going up from left to right, well, over the whole thing. So that's -infinity to positive infinity. We are never decreasing. So your interval of decreasing is none. Even, odd, or neither. If I fold it on itself, it's not going to be the same, so it's not even. If I turn it upside down, hey, look, it looks the exact same. So that tells me that I am odd. I'm positive, and again, all these intervals are based off x values except for the range. But here, I'm positive from this kind of point going upwards, that x value is 0, and I'm going up forever. And we're using parentheses because we're not either positive or negative at 0. And then negative is the rest of it, starting from -infinity, always starting at the lowest, going to the top at 0. Here, we're going to talk about some of the transformations. I've listed all the transformations. I would like you guys to go in and say which letter goes with each transformation, and then give the range of values for that letter for which these transformations occur. Pause the video here. Okay, so here are all of our range of values. And just be careful because this is the opposite of what you think. When h is greater than 0, it's going to look like x minus h, so which is why you shift right. And when h is less than 0, h is a negative number, it becomes minus a negative, so you have the x plus h. Other thing you should remember that we need to do our transformations in a specific order so we don't mix things up. So if there's an order question, it's always starting with where you're shifting with your h value, then what's going on with your a value, and then finally your k value. Now we are going to graph g of x. We're just going to take our our parent function, and then apply the transformations. And here you have a loose outline of your parent function, what it should look like, just to see the difference between what our parent function and what we finally graph in the end is going to look like. So first, our transformation, starting with our h value, we're going to go to the right 1. And that's going to affect our x values. So that means we have to add 1 to all of those x values because we're moving to the right. Next, we need to think about what our a value is. We're going to have a vertical stretch by 2 because our a value is 2. So that means we're going to take all of our y values, multiply it by 2, and then our final transformation is we're going to move down 1 because of our k value. So we're first going to multiply all these values by 2 and then subtract 1. So here for our x values, we're adding 1. So this is -2 becomes -1, -1 becomes 0, 1, 2, 3. And then we take all of these values, multiply them by 2, and then subtract 1. Negative 8 times 2 is going to be negative 16, minus 1 is negative 17. Negative 1 times 2 is negative 2, minus 1 is negative 3, is negative 1. And then here, 1 times 2 is 2, minus 1 is 1. And then 2 times 2 is 4, minus 1 is 3. So here are our points. Ooh, there's not our points because Ms. Marshall didn't write the parent function correctly. That should be 8. So 8 times 2 is 16 minus 1. That should be 15, which makes a lot more sense. Now we can plot these points. So here are all our points plotted. We can't get these on our plane right now just because it's a little bit zoomed in. So that's okay. Just kind of know they're off there, up here, and down there. Then I also want to mention this point right here. It's kind of like our vertex because it's our h comma k point, because h, k, 1, negative 1. However, it's not really a vertex here. It's good to note that that's our center point, is where things kind of move and change for the cubic. And then from that center point, if you wanted to use a little graphing trick, if you go just 1 point to the right, only 1 point, the point directly to the right of it, and you count its slope up to over 1, you can see the connection there to our a value. And it's only the point directly to the right. And you have to be very careful. You can use that trick to help you graph, but similarly to quadratics, the slope is changing. So you can only use it for the point directly to the right. Flipping the paper over, I would like you guys to try this one on your own. Graph it. Pause the video here. And here is our answer. We had to go right 3, and then that's going to take our parent function, and it's going to add 3 to all of those values. We're going to reflect over the x-axis and have a vertical shrink by 2. So that can be taken care of all by multiplying our y values of our parent function by negative 1/2. And then you do that with all of your values. These are your outcomes. And then here you can see the graph. It's going to look like it's going the opposite way, and that's what that a value does when it's negative. And then it's also condensed a little bit. And you can see this is our center point right there, 3, 0. And if you go 1 point to the right here, it's down 1/2. So you're not going down 1, right 2. You're just going directly to the next line, and you're shifting down 1/2. And that's where you can see the a value or your slope. And again, very careful using word slope because the slope is changing. But just to get that second direct point, if that is something you're comfortable with, go ahead. And you can also see the shrink, because usually this point is 8 away, but then it shrank by 1/2, so it's now 4 away. And that's from your center point there. Next, we are going to talk about being given a graph and then writing it. And we are going to be writing it in the form f of x is equal to ax minus h cubed plus k. First, we're going to start by finding this center point, and that's at negative 1, 2, negative 2. So that's negative 2, negative 2. And that gives you your h and your k value. So we just substitute them in. I'm going to change this to y because f of x is the same thing as y. So minus a negative is plus 2 cubed, and then minus 2 out there. And then we need to just find what our a value is. So we can use our little trick where we find the point directly 1 point over, and then we can count the slope. So that's up 1, 2, 3, right 1, 3, right 1. So that tells us our a value is 3. So we can say that y equals 3x plus 2 cubed minus 2. And that's it. But let's say we are not comfortable with that, or it's looking a little funky and it's not being clear. You pick a point that is not your center point. So let's see, this is the point -1, 1. And you substitute it in for x and y. So here our y is 1, our x is -1. And we don't know what our a value is at that point. +2 cubed -2, and you solve this. And that's another way you can find your a if you were not comfortable doing the counting. So 1 equals a. So this is 1 cubed, which is just 1. So that's just a -2, add 2 on both sides. So a is indeed equal to 3, reiterating that this is indeed f of x equals, and that is our final answer. And this trick goes along with any polynomial given to us like this, that you can find your center point and your hk and a values.